All right, let's jump right in. We're going to talk about something that is absolutely mission critical when you're dealing with regulated AI, and that's the problem of silent failures, the kind of issues that can build up totally under the radar. So in this explainer, we're going to unpack how you can actually spot these subtle changes long before they snowball into a real incident. And this, right here, is the idea we have to wrap our heads around. It's not always the big, spectacular crash that's the real threat. It's the slow, quiet erosion of performance, the gradual decay of trust. And frankly, that's what makes it so incredibly dangerous. So, what do we do about it? That's what this is all about. We're going to look at how these silent failures actually surface in our systems and, more importantly, how you can build AI that is designed from the ground up to detect them. Now, when we say change in an AI system, we're really talking about two very different things. Think of them as the two main characters in this story, drift and anomaly. They might be related, but believe me, they behave very differently, and you've got to be on the lookout for both. Here's an easy way to think about it. Drift, that's like a slow leak in a tire. It's this gradual loss of pressure over weeks or months. It quietly eats away at performance and your confidence in the system. Anomaly, on the other hand, that's the sudden blowout on the highway. It's an immediate, unmistakable deviation from what's normal, and it demands your attention right now. See? Both are big problems, but you need different ways to spot them. And drift, well, it can creep in from just about anywhere. Is the data you're feeding the model from the real world slowly changing over time? Of course it is. Are your users interacting with the system in a new way? That can cause drift. Even a tiny change in the software environment around the model can cause its behavior to slowly drift away from where it started. And listen, this part is really, really important. Not all drift is a bad thing. In fact, some of it is expected. The goal isn't to freeze your system in time. That's impossible. The real goal is to detect the drift. It's about making the invisible visible so you can understand what's happening, manage it, and most importantly, stay in control.
Okay, so how do we get good at detecting it? Well, this is where we need a bit of a mind shift. Just staring at a single accuracy number on a dashboard, that's not going to cut it. We have to go deeper and look at the AI's actual observable behavior. In these high-stakes, regulated worlds, even the tiniest change in behavior can have huge ripple effects. Just imagine an AI that helps prioritize samples for quality control. If its ranking behavior drifts just a little bit, you could end up testing the wrong things at the wrong time. Or what if an AI that recommends product batch releases starts to behave differently? That could throw off your entire supply chain. This isn't just a number on a spreadsheet changing. It's a real-world behavioral failure with serious implications. So we know we need to monitor behavior. But how closely? How intensely? Well, the guiding principle here is actually pretty simple. It all boils down to this. The more authority you give the AI, the more rigorous your monitoring has to be. It's a direct relationship.
We can pretty much break this down into 3 levels. First, you have assistive AI. It's just providing info, so a slight delay in detecting drift might be okay. Then you have decision-shaping AI. It's actively influencing human choices. For that, you need timely detection. But then you get to the top level, execution influencing. This is an AI that can directly trigger actions in the real world. For that, you need immediate, automated detection and a response plan. The stakes are just way too high. This framework here shows us how to actually manage all of this. It's called an IT/OT control plane. Let's just break it down real quick. Up top, you've got the control plane. That's where you set the rules and policies. In the middle is the execution plane. That's where the AI is actually doing its thing. And then at the bottom, the evidence and audit plane is capturing a permanent record of everything that happens. And here's the big insight. As a system's authority goes up, its connection to that control plane at the top has to get tighter and stronger. More authority absolutely demands more robust controls, crystal clear escalation paths, and direct human oversight, period. Let's look back at that diagram. See those yellow approval gates? And the red lines for things like emergency rollback and escalate? For any high-authority system, those aren't just nice-to-haves. They are non-negotiable. They're the safety features, the circuit breakers that are designed to stop a silent failure from turning into a full-blown catastrophe. And that brings us to what might be the single most important takeaway from this whole explainer. You can't just bolt on detection at the end, like some kind of add-on. It has to be a core prerequisite baked right into the system's DNA from the very first day. When auditors or incident responders go back and look at systems that failed, They find the same mistakes again and again and again. People were monitoring if the server was on, but not if the AI's behavior was sane. They failed to define a clear line between what's normal and what's a problem, or they got bombarded with so many meaningless alerts that the humans just started ignoring all of them. Sound familiar? This is so critical, it is absolutely worth saying again, because this changes everything about how you build these systems. Detection is a design requirement, not an operational add-on. So what does that actually look like when you're designing a system? It means, from the very beginning, you are defining your drift metrics, you're setting explicit, clear thresholds for what counts as an anomaly, you're mapping out who gets called when something goes wrong, and you're testing those escalation paths. And you're making sure that evidence capture is automated at every single critical decision point. Now, just to be perfectly clear about our scope here, what we're doing is explaining the mechanics of detection. We're trying to prepare your teams to think about and spot this kind of change. What we are not doing is telling you which specific monitoring tools to buy, and we are absolutely not approving or authorizing any system for real-world use. So the bottom line is this: AI systems are not static things you just set and forget. They live in a constantly changing world, and because of that, they themselves will constantly change. In a regulated space, you don't stay in control by trying to prevent change from happening. You stay in control by building smart, robust detection systems that make you constantly aware of. So I'll just leave you with this one final question to take back to your teams. We have to assume that sooner or later, things will go wrong. The real question isn't if it will fail, but how. When your system fails, will it do so silently, invisibly? Or have you designed it to fail visibly, where you can see it, you can catch it, and you can control it?